In this video, we're looking at bearings. So there's several different types of bearings, but the first one you're probably most common with is what we call compass bearings. You've got north, northeast because it's the north side of northeast, northeast, and so forth, east, south, west, all right, all the way around. Those are your normal compass bearings. We also have something known as true bearings, which most of your problems in mathematics are now going to be given in true bearings. So this is an angle measured clockwise from north. So for example, if I had a line down here and I said I want to find the bearing of that, you always start from your north line going clockwise around till you hit that line that we drew. Now, this is obviously between 180 and 90, so it could be 120 degrees. Now, I would write this as, let's also change it as A. This we would write as the bearing of A from O. So O is usually just origin. You can have different letters there. Is 120 degrees. So you read this as the bearing of A. That's the place we're going to. From O, which is like your starting point. Okay? So, next thing I want to talk about quickly is what we call opposite bearings. So, this is just a useful little trick to help find some bearings quickly. So, if we have one here where we know that the bearing of B from A is 60, okay? I can then note that the bearing of A from B is going to be 60 plus 180, which is 240. All right. So how this works is if you have theta, you have some sort of bearing. In our case, it was 60. All right. So over here, we said our theta. Let me zoom in a bit. Our theta was 60. Okay. Now the opposite bearing. Okay. So that B down there, the bearing of A from B that's known as our opposite, is theta plus 180. So it's going to be 60 plus 180, which was 240, which is what's there. Now that's only if our first bearing that we're given was less than 180. Now if it's greater than 180, it's just going to be theta take away 180. So what in this case, let's hypothetically say we're working backwards. We have 240 take away 180. That equals 60, which was the opposite bearing. Okay? All right, so let's do an example. We have a bushwalker walks 4 kilometers on a bearing of 55 degrees from A to B. How far east is point B from point A? So the first thing I want to do is draw up a quick sketch of a diagram. Okay, so the first thing I'm going to do is I'm going to say here is A, and we know he walks on a bearing of 55. So the first thing I'm going to do is draw my north line. Okay, and I know it's a bearing of 55. So it's going to be something like, maybe like that. Okay, so that's 55 degrees there. Then over here, we have our B. So that's 4 kilometers. I'm just going to put it in there. The question's asked, how far east have we gone? Now, east would be literally just this distance here, okay? Because remember, over this way is east, okay? From A. So I'm trying to find that distance there. Now, we need to put some more information in, because obviously, if I was to draw this triangle here, I don't have enough to find X as it is. What's special about the compass, north, east, south, west, is that this angle here is 90 degrees. So let's say I call this down here theta. Okay, I'm going to zoom in so I can write a little neat. Theta is going to be 90 take away 55, which gets us to 35 degrees. Okay, so if I redraw that triangle just real quickly, this one here, we know that the right angle's there. That was 35. That was 4 kilometers. I was trying to find this distance down here. I now can use trigonometry. And with trigonometry, what we always do is label our sides first. So there's my hypotenuse. From this angle here, this is my opposite and this is my adjacent. So if I write SOHCAHTOA Toa over here, I then say, oh, okay, well, X is A and 4 kilometers was H. So I'm looking at something with A and H. So Ka, so I know I'm dealing with cos. All right. So now I can fill that out. So I've got cos 35 is going to equal X over 4. Let's multiply the 4 over here. So that cancels that out. And I'm left with 4 cos 35 equals X, which you can just put in the calculator, which comes out as 3.28 if I round up kilometers. So the bushwalker traveled 3.28 kilometers east. All right, we're going to have a look at another problem here. So this time we have a helicopter that flies on a bearing of 140 degrees for 210 kilometers, then flies east for 175 kilometers. How far east has the helicopter traveled from its starting point? So the first thing we're going to do is draw a starting point. All right, so this is our starting point, and I'm going to label it S for start. Now I know that the helicopter travels at 140, a bearing of 140. So as always, draw my north line, and then 140 is going to be down roughly around here. So that's 140 degrees. All right, so down here. And that was 210 kilometers. So I now know that the helicopter's at this point. Once it gets to there, we know it travels east for 175 kilometers. So we're going to go this way for 175 kilometers. And we end up over here. All right, so let's label that E for end. Now we need to create some sort of a triangle, or we need some information here. We know the 175 is straight. That's what we need. It's going east. What we need is how far east has it traveled in that first part of the journey. So really, we're trying to find how far it's gone there. All right, we want to find this X up here. So knowing my normal math stuff, all right, so this here, that was a right angle because this is east, which means if that's 90, okay, then I know that this in here is going to be 50 degrees, this angle right here. Okay, so I'm going to redraw this triangle for me, just here. I know that was 50. I'm trying to find that, and that's 210 kilometers. Okay, knowing that, I can start to label my sides. So we have our hypotenuse, we have our opposite, and we have our adjacent. So, again, SOHCAHTOA. I have A and H, so I'm looking at cos again. So this time, remember, cos theta equals A over H. So let's substitute in our values. Cos 50 equals X over 210. We're going to multiply our 210 over here because that cancels that out and we're left with X. So 210 cos 50 equals X. So X is going to equal 135 kilometers. Okay, so if I go back up here, this X is 135 kilometers. I know that down here was 175 kilometers. So how far east we've traveled, east distance will equal 135 plus 175, which equals 310 kilometers.